All right, finally. Okay, so my name is Tom Brennan. I'm the engineering manager for Sol-Ark, and this webinar is more about education than it is trying to sell anything. It's trying to get you to see the nuances between the different types of solutions that are out there, and pick the best one that suits you. So with that, we're going to talk about different storage inverters. We're going to talk about the basic fundamental problem of solar plus storage, because it's a pricing problem. It's the reason why so few people get batteries with solar. Only about 2% in the country. We're going to talk just real briefly about our company and what our 8K system can do. We'll talk about the different modes that are available in a lot of different inverters, the smart inverters these days, including ours. And some of the ways that we can use them, especially in new ways, because grid utility companies are not wanting to buy back the power that they used to. So we have to change the way that we do things. And then we'll talk about the different types of battery-based storage inverters out there, what is good about certain aspects of them and what is bad about certain aspects of them, because we compare specs and we compare data that is readily available. So anyway, there's good and bad about all, and we just want to pick the right solution for the right application, whether it's on-grid or whether it's off-grid, and or time of use. Time of use is where we're using the battery to reduce how much power we purchase from the grid, and then cost of installation. Then also we'll talk a little bit about how we can make some of these solutions more affordable, especially in our case, and then we have a large engineering team, so we're doing a lot of things in terms of releasing features and what's coming in Q1 and Q2. Then we can take questions, but I encourage you to unmute your phone and ask questions as we go. And then if there's time, we will talk about different battery solutions that are out there, and the costs and the cycle count and lifespan, if there's time. So with that, let's go ahead and get going. Okay, so the storage, the solar storage price problem is that a typical 10 kW PV solution will cost about $25,000 installed. That's assuming some standard rates of about $1 per watt installation cost, about $1 per watt for solar panels and mounting, and then the electronics tend to be about half $1 a watt, and it varies. The coasts are certainly more expensive, and the islands. So, but overall, on the lower end, it costs about $25,000 or $2.50 per watt of PV installed for a grid tie system that doesn't support batteries. And then when we implement a system with batteries, first of all, a battery-based system is less efficient, so we have to add about 10% solar PV to that system to overcome the inefficiencies of battery-based systems versus grid tie systems. Also, when we add batteries, the batteries are expensive, the cost of the install is more expensive, and overall the price just about doubles when we go from a grid tie solar system to a battery-based solar system. So we're looking about $50,000. So that is an instant turn-off for most customers, or a price shock. So what we're trying to do in the case of our company is, and a lot of companies are trying to do this, is get the cost down of battery-based systems. And we're doing it in various means. Number one is to increase the efficiency. In our systems, there's no penalty for a battery-based system. And then also trying to bring down the cost of batteries in multiple ways, via numbers of cycles or cost of the batteries, or more innovative ways to use the power, but not use the power of the solar panels, but not use the power of the batteries and cycle them so much. Okay, so in our goal is that a battery-based system only costs about maybe $6,000 more than a pure grid tie system, but that is going to depend upon your batteries and and our batteries are optional in our case. So okay, so that's the fundamental problem. So a company overview of us is we're a veteran-owned engineering company in Texas. We came from the defense and government engineering backgrounds. The Sol-Ark AK is one of the most efficient battery-based inverters in the world. It's won multiple awards, and we've been in business for about over 5 years, and we are very focused on our customers, and we have had no customer returns to date, and that's because that's how much we care about our customers. So anyway, just a little bit about us. Okay, so the 8K, what does it do? It is an all-in-one system, hybrid inverter, that is built for both on-grid and off-grid needs. It's 8 kW continuous and 20 kilowatts peak power. The peak power is for when you're off-grid, because you need a lot of energy to start motors and pumps and other things. And the 8K is for really on-grid use for selling back power. There are 2 MPPT controllers built into the system over here with 2 inputs each, so we can support up to 4 strings, up to 500 volts, and about 9 amps per string, or 18 amps total per MPPT, and it's self-limiting, so we don't have to worry about a lot of things. So that saves us a lot in wiring. Then in addition, there is a couple different options here. You know, we have our UPS loads. We also have our AC grid input and output with 50 amp 12 kW pass-through from the grid to our loads. And then also we have a generator output here, which can either support a small generator, or it can support AC coupling of already existing solar panels, or we can use it as an output in what we call the smart load. So we use that when we want to run loads that are large and not utilize the batteries or do time of use shifting. So that it's a programmable input-output. As far as the design, it's a very efficient DC transformerless design. And with that, we're able to achieve efficiencies that we haven't seen before. It's more efficient than DC coupled, and it's more efficient than AC coupling. Although we can't AC couple to existing solar panels on the gen input. The 48-volt batteries are, a 48-volt battery type solution is standard. There's lots of solutions out there. We're battery agnostic. So there's lots of options available to you, including no batteries. If you want to just get the system and then add batteries later, that's certainly possible, as your budget allows. Something that's very unique about us is because we come from the defense area, we have the option of surviving an EMP, electromagnetic pulse, and solar flares. Our unit was hit over 140 times at twice the level that the government requires, and the system, the solar panels, and the appliances plugged into it all survived. So that's something unique to us. Standard 5-year warranty and 10-year optional warranty. As far as the system, it's about a third the size and a third the weight of a traditional DC coupled transformer design. That is on purpose. We did that for efficiency and compactness. It is very simplistic. So, you have a single on-off button, as well as a PV shutoff required by NEC. And the screen is a nice color touch screen display that a customer can understand, although you can get to detailed screens, as we'll see throughout the slide presentation. But it instantly shows you what your solar panels are producing, what the grid is either putting back to the grid or consuming from the grid, from your loads, and going in or out of the batteries. And this is all a simultaneous transfer switch, so you can have any amount of power from any source being channeled simultaneously. So it's a very flexible system. Nice, quiet, variable speed fans, and wiring knockouts, Wi-Fi is included, all those sort of things. Also, I forgot to mention there's some battery temp sensors available connections here, an auto generator start, PV rapid shutdown that's SunSpec compliant, and we use external current sensors for some of the modes that we're doing, and then battery communication. We support CAN bus and RS-45 for like lithium batteries and things with a BMS. So this is just a quick overview, and I want to go into some of the modes that a lot of these inverters are using these days. Okay, so this is a standard. A lot of battery-based systems have this. This is off-grid mode, and of course we will have it. And this is all automatic. So if the grid is down, it's just going to basically not use the grid, and it's going to take the solar panels, which we support up to 11 kW, and provide power to both the home appliances and recharge the batteries. In addition, we support generators. If the batteries get, if we're truly off-grid, maybe we'll want to use a generator on several days of cloudy days, and we support generators from 4 to 30 kW. They just need to be 240-volt generators. And then also we can support AC coupling on the solar, both on-grid and off-grid, up to 7 kW on this generator port. And this is just down here. This is just showing you some of the graphical user interfaces that we use as programming for the system. So a customer can program this, although we have lockout features if needed, but it's very easy to program for an installer and understand. The main things that an installer will want to program is basically battery capacity and charge rates and what sort of modes they're using. Okay, so this is off-grid. So here is a standard grid cell mode. In this mode, batteries are optional, and we're just feeding back the power to the grid as it's produced. Of course, it goes to the house first, and then whatever excess from the house and the loads, it just goes back to the grid. However, so many states are dropping net metering. Even California looks like this year. So with that, we've seen it drop in Hawaii, probably this year California, some places in Texas, North Carolina, Kansas. A lot of states will not pay you. They may pay you 5 cents while they charge you 15 cents. So that's why just pure grid tie systems only are not. The payback period is not working. And that's where we can take advantage of solar plus storage. So with that, there's some unique modes. Yeah, is there a question? Okay. All right, so there's some unique modes to the Sol-Ark 8K, and a few other competitors have that out there. In this case, we use CT sensors on the mains. They're provided with the system. But on the mains of the residential house or the light commercial, these are measuring the L1 and L2 on the main meter. And what we're able to do is, we don't have to get a net metering agreement. In some cases, a net metering agreement or connection agreement the utility will charge $70 a month. So that's pretty expensive. So what we can do is we can use our CTs and put it in limited home mode and just zero the meter during the day. And so we will always power the loads, but then we're also shoving back power to the rest of the loads in the house that aren't on the UPS side, and canceling out the other power in the house. So effectively, there's zero power coming from the grid during the day, and then at nighttime we just use the grid at nighttime because we're not using our batteries. However, if we have the right battery technology, like a partially charged carbon AGM, or we have lithium batteries, or we have a super large battery bank, we can do something better. What we can do is we can use these CTs all day long and all night long, and we can effectively zero the meter all the time. So we'll use solar during the day to zero the meter in the whole house, and then we'll use storage or batteries to zero the meter at night, and the grid is basically a backup for bad solar days. So this is basically net zero export and time of use for using the batteries at nighttime. Okay, and then this is just showing you how it's set up a little bit. It's based upon a time schedule, and it's pretty easy to program and understand what's going on. Again, we can use either percent SOC on the batteries, or we can use voltage, whichever you prefer. A lot of customers prefer our percent SOC because it's easier for them to understand. They don't understand watts or volts and amps. They just tell me how full the batteries are, and they can understand that. Okay, so in addition, we can use even more features. In this case, we're using what's called the smart load or the generator port, and we are adding some high-powered appliances. Let's say it's a heat pump, or let's say it's a hot water heater, or pool pump, or circulation pump, something like that. We can put those on the smart load, and what this does is the system will automatically tell when we're producing a lot of power from solar during the day, and it will turn those loads on. They're non-critical loads, and it just time shifts so that these loads run during the day and not at night when we pull power from the grid or from the batteries. In addition, when the grid goes down, excuse me, let me. Okay, I just wanted to mute there because we got some echo. But in addition, when the grid goes down, this smart load acts in an off-grid manner and works just the same way. It uses, when the solar's producing a lot of power or the batteries are full, and this is all fully programmable, it will turn on these loads, so we can have hot water and run these loads off of solar power produced instead of running them off batteries. So this allows us to use a much smaller, or at least about a 30% smaller battery bank than we would normally need, because we're running large appliances on solar power rather than battery power. Again, if you have a question, please unmute your phone and ask.
We're trying to ask a question.
Check the message.
Oh, okay, that's fine. Okay, so from what let me ask here. From what I'm understanding, we can do up to 7 kilowatts AC coupled as well as 11 kilowatts DC coupled at the same time. Ah, good question. Let me go back to that slide just a little bit. Okay, so that's not entirely true. No, we can go up to 11 kW on the DC side of solar directly to the system, and we can do up to 7 kW AC coupled on the gen input, but we can't do max this and max this. There are some limitations because we have a 50 amp breaker here, so to the grid. So it's somewhere. I need to check the exact amount, but there's an overall limit of DC plus AC. Somewhere I believe around 14 or 15 kW. Okay.
We have a question about the smart load.
Okay. What's that?
If we put a water heater, put the smart load on a water heater, do we need to go into, like, let's say it's usually like a 4,500 watt electric water heater? Do we need to go in there and change those elements, or is it going to be okay with, 4,500 watt water heater on 30 amp breakers?
So that's a good question. If you have a very large array and that's able to supply a lot of power, you can do that. You can leave that. I would only do the lower element as part of that. But if you want to do a better job of it, I think it's better to, so there's two elements in a hot water heater. Typically, we would just do the lower element, and I would tend to suggest changing out the element for a 2400 watt element. That would be far better because it heats the water up more slowly throughout the day, and it's just going to work better. Or leave that element in there and just run it on one leg or 120 volts, and it'll only consume about 1300 watts instead of the full 4500. In addition, the smart load has the ability on the screen to just, if you just press the and hold the light bulb icon, there is a manual override to turn it on manually, and it'll turn it on for about 4 hours, and then it'll kick back into its normal mode.
Yeah, we typically if we put a water heater on there, we might put in some kind of a transfer panel, so the water heater's in regular operation, the water heater's running off the grid, and we would tell them, if power goes out, you can use your you can put your water heater, transfer it over to the smart load, and so it's not always depending on the smart load to heat it.
Well, in our case, we can program it. So we can set it to always be on when it's on the grid, or we can tell it to be on when it's producing so much power in terms of solar power, but it will always use the battery state of charge when it's off grid, so that it's waiting till the batteries are full before it starts charging. It starts turning on those large loads. But you will get a little bit better results by lowering the wattage of that element.
But you can program the amount of the smart load. You can program the amount that is sent to the element, or no?
No, you cannot program the amount of power sent to the element. That is determined by whether you wired it up. That is determined by your element, and it's determined by whether you did 240 or 120 to it.
Okay.
Does it hurt it at all to have an imbalance? Like, does it hurt the Sol-Ark?
Not at all. So there are 2 inverters inside the system, and each is a very large inverter. So they don't care how much you run each. One other question on the user interface screen for batteries, it showed percent SOC or voltage. What was that about? Is that allowing the low battery cutoff to be controlled by either stat? Yes, you can decide in the programming of the system whether you want to use percent battery for how you set everything, or whether you use voltages for the thresholds that turn everything on and off. Of course, your charge voltages are all set by voltage, but everything else that is decision-based in the system can be either voltage or percent SOC. Decision-based. Let's see. Smart load would be ideal to charge EV when the battery's full. Oh yeah, we have customers using the smart load to charge their EV vehicles already. Okay. So, and actually, here we go. Here was the smart load, and this again is showing you that we can use the either voltage or batteries, or percent SOC to turn on the smart load, and then when the batteries get down to maybe 5% below or 95% full, it will turn them off, and that's how this gets selected. In addition, when we're on grid, it will use how many watts the PV is producing to turn that load on and off. And then if we want to use it as an AC coupled input for other microinverters or string inverters, it doesn't use this. It uses more some other things. So, okay. All right. So let's take a look at a comparison of different storage inverters when we're on the grid. I tried to cover the different modes. Did anybody have any questions about modes real quick?
And if we do it, it's absolutely not going to work if we try to do a generator on the smart load input, right? You can't put a little generator into the smart load input?
Yes, you can, but then you can't use it as a smart load. So it's only one port. It's an input or output. You can't use it for both. So if you want to use the generator port for a small generator, then you lose the smart load capability. That's all. And most of our off-grid customers, they'll end up using the grid as the generator input and using that smart load. Okay, So let's take a look at the on-grid inverter comparison. So if we look here, we've got Sol-Ark 8K, we've got Outback Skybox, Pika, this is basically SolarEdge, Darfon. Actually, in this case, we've got 2 Darfons to sort of make it a fair comparison. Outback Radian, Schneider, along with a couple MPPTs, and then I'll get to the stackable question in the next slide. Sonnen, along with the string inverter, because this is AC coupled. Magnum, along with their GT500s, which are microinverters, AC coupled, and 2 Tesla Powerwalls, plus a string inverter, because it's AC coupled as well. So if we look across here, you know, and we're only talking about on-grid. You know, on-grid we care about inverter continuous power. So that's why you want lots of power when you're on-grid, because you're mainly selling back to the grid or selling back to the household. And we care about this PV to AC efficiency. So here we can see that these are primarily on-grid type of solutions, and they have good efficiency and they have decent cost. Actually, I'd say good cost and I should say decent efficiency. Some are better than others. And then here, what we have is, if we look at the AC coupled solutions like Sonnen, Magnum, and Tesla, then these were made to be very, you know, good in efficiency. However, they're AC coupled. There's more things involved with them. They're using they tend to be pretty expensive because of their lithium solutions. So overall, they have good efficiency but poor cost. And then if we look at some of the DC coupled solutions, which are Outback and Schneider, they have not so good efficiency because they're going from the solar panels through a charge controller down to battery voltage and then back up to AC. And their cost is a little bit high because they're transformer based. So ideally, some of the newer on-grid solutions tend to be better on-grid, and they're pretty decent in cost as well. Okay, so I'll get to some of the other questions here in a little bit, but I want to point out, you know, let's see, couple things. You know, we're seeing more 5/10 year warranties. Also, by the way, for those of you, Sonnen uses the Outback Radian inside, so the specs for Sonnen, although it's AC coupled, so they tend to be more efficient when they're on grid because it's just the grid tie inverter. But a lot of the specs for Sonnen are similar to Outback. What else? AC. So here's, you know, some systems can handle both AC coupling and DC coupling. So that's something to look for. Here's one disadvantage to us, and I'll address this in a little bit. We do not support UL 1741 SA or Rule 21 or Hawaii's HECO 14H. So this particular standard is when you want to sell back to the grid, and we currently don't support that. So we use limited home mode and time of use, and for all our installs in Hawaii and California. So we're a grid interactive inverter, and we're listed on the CEC in California, but we don't sell back to the grid in Hawaii or California as yet. Okay. But I'll address more of this later. Okay. So the thing I want to point out is, you know, in terms of the Sol-Ark 8K, you know, we're similar cost as the other grid inverters there. We tend to be, you know, 1 to 2% less solar. We focused on very, very high efficiency in our inverter, but in addition, we're much more efficient than the traditional battery-based systems, and use a lot less solar there. Okay. So here is where I want to talk about really getting into the battery usage and not just the on-grid usage. Here in the off-grid usage, we really see how efficient the inverter is. So first of all, let's start at a couple here because it's a pretty busy chart. When you're off-grid, that's when peak power matters. It's for starting up those motors. It's for, a lot of our appliances are switching mode power supplies. So, and a lot of our pumps, that's air conditioning and air conditioning, motors, power tools, saws, you name it, well pumps. So that's where all this peak power is needed. And basically the Outback Skybox has the same power as its, same as continuous, and the peak power of the storage is not very large either. So these are really not off-grid solutions. And then also the Pika solution is not really an off-grid inverter either because it doesn't have generator support. It turns out it's kind of difficult to sync up with generators. It can be rather messy. So these Outback Skybox and Pika and SolarEdge are really not focused on the off-grid market. However, here's where the traditional battery-based solutions work well. Is in they've got lots of peak power. They've got big transformers in them. So the Outback Radian, the Schneiders, the Magnums, especially Magnum, lots of peak power for starting up a lot of things, and that's what we care about when we're off-grid. So these make good off-grid inverters. We really over-designed the Sol-Ark 8K, and we have 20 kW of peak power. The other areas, let's take a look at some other things having to do with efficiency. Now, we hear a lot about these newer 380 volt systems. Pika and SolarEdge have a 380 volt marketing solution that says, our system is 380 volt batteries. And it sounds good on the surface. However, the problem is that the battery internally is only 50 volts. So every time so let's take the SolarEdge for example. It is about 96.5% efficient when going from PV to 380 volts. Then when we go into the battery, the battery has to convert 380 volts to 50 volts internally. That is done at only 94.5% efficient. So we lose 9% every time we go into the battery, and then when we come out of the battery, we lose 94.5 plus 96.5 plus the auto transformer, which is 3%. So coming out of the battery, we lose about 12%. So overall, the round-trip efficiency of some of these 380 volt battery solutions are, part of it's the inverter, but also part of it's the battery technology. So we lose about 15 to 21%. We focused very hard on 48 volt battery efficiency. A DC transformerless design. So we only lose 7% when we go into and out of the battery. That means a lot less solar panels that need to be installed on the system. And then likewise, I try and talk people out of using AC coupling for off-grid or for time of use because this is why. Tesla is decent. They did a decent job of design there, but the traditional using an AC coupled Radian and a Magnum, the problem is the AC charger efficiency is 85%, so the round trip efficiency is somewhere between 25 and 30% from solar to battery to usable AC power. So it's a really big loss of solar energy. So please don't consider AC coupling unless you absolutely have no choices. And then here's where actually the DC coupled traditional solutions aren't all that bad in terms of, and I guess that's a large reason why they're still used for off-grid purposes. They're good in terms of peak power, and they're good in terms of in and out of the battery efficiency. Okay, so a couple of the things to notice in this chart is transfer time. So a lot of the basic grid solutions that connect to the grid that are meant to be mainly grid connected, they have a very slow response time, kind of like a generator, maybe 1 to 2 seconds. This glitches a lot of electronics, all of your electronics, and you're going to be resetting your DVRs and all that other stuff. But some of the systems out there have some good transfer times. The 16 milliseconds is kind of an entire cycle, so that tends to glitch the computers. Schneider was really good in terms of the 8 millisecond time. We really focused on that heavily because we are used in computer server rooms, and so we have a record-breaking 2 millisecond transfer time from when the grid fails to when we supply power. In addition, we have some very fast reacting stuff inside our system that and 6 technologies that allow us to survive EMP and solar flares and other things. So we were really careful about letting transients go through the system, or not go through the system, I should say. Okay. So here's one question that comes up. Let me see here. Okay. So I guess I want to just say that because of efficiency, we tend to use about 5 to 20% less solar panels than other systems because of our efficiency. Typically, it's about 10%, and anywhere from 5 to 20% less battery capacity because of smart loads and because of efficiency. So that's a significant savings. Another drawback here is we don't support parallel stacking. It gets complicated. We can have we do have multiple systems installed in computer server rooms, but they have dedicated loads. They work together on the grid or on a generator, but their loads are separated. So we have no plans to do anything about parallel stacking, and we don't do it to a vast degree because we have so much continuous and so much peak power, so we don't see the need to do it a lot. That was one of the questions about stacking. In an off-grid system, for example, when the battery is charged, demand for loads is met, and there's excess PV power, how does Sol-Ark respond to that? In an off-grid system, for example, when the battery is charged, demand from the loads is met, and there's excess PV power, how does the Sol-Ark respond? Basically, the Sol-Ark doesn't create any power, but that's why we have the smart loads. Smart load allows us to use that excess PV power and turn on some heat pumps or turn on a hot water heater and heat hot water. So if we're off grid, we're taking that excess energy and using it for non-essential things. Okay. All right, so let's talk about the reduced install costs of storage inverters. So a couple key things is making it easier for the user to understand, because if they don't understand, they're calling the installer. So the best way is just to make it as easy as possible so that the user doesn't have to go through multiple different displays. Text displays tend to be a little bit troublesome, so a color touch display that's graphical tends to be very useful, and also wireless monitoring, so that's helpful. Some of the other ways to reduce the install cost is, the way the system is designed. A couple of these like Darfon and Outback Skybox and us, it's an all-in-one package, put it up there and all the wiring kit area is included. So that's another way to reduce the install cost. Another way is to make batteries optional. And by the way, I think batteries are optional here on the Skybox. But utilizing the smart loads can help us, and use PV power to run big appliances can reduce the battery size, and that can reduce the power or the battery capacity size, and thus the cost. So in terms of Sol-Ark 8K, we see typically about 10% less solar needing to be installed versus other storage inverters. So there's a 2.5K savings there, and about 10% less batteries, which depends upon the battery technology that you're using, and if you're using smart loads and some of the batteries that we might recommend. Let me take a look. Okay, so Sol-Ark is not capable of curtailing PV production in case there's excess PV. No, Sol-Ark can stop. Yes, Sol-Ark can stop the PV production when there's excess PV. It just doesn't produce it. It won't produce any more than it needs in the batteries and the loads. Okay. All right. So how do we make these things more affordable? And by the way, I've tried to show you some of the screens that we would see. This is like a debug screen. If we hit the battery icon, we'll see exactly what's happening in the battery, the loads, the inverter, the grid, and solar. You know, these all-in-one units, you know, they only cost about $2,000 more versus grid-tie only inverters, and that can make the cost of adding battery-based systems much more affordable later. Also, on the 8K, you know, we utilize a faster install because it's just like a string inverter. You don't need all these batteries. You're just wiring in the strings and wiring up the grid, and if you want to wire up critical loads, that you can do that. Wi-Fi monitoring is included. Also, current transformers are included for zeroing the meter and for the different modes. We support SunSpec rapid level shutdown. So depending upon which NEC code that your state is using, it can be about $100 at the string level per string, and about $30 per module if it's module level shutdown. Or another way to get around this is just to use ground mounting. And it's looking like there's some nice solutions coming out there that are not that bad. So and then you don't even need rapid shutdown and so forth. We can also add on a battery-based system to an existing grid tie system with AC coupling, and if it's more than 7 kW, we would take off the string inverter or the microinverters for anything over to 7 kW and go to direct. As I said, we're expandable system from 5 to 36 panels or 11 kW, and we need fewer batteries because we're so efficient and because we can utilize smart loading. And we have some tools that can help you identify, and staff that can help you identify how many batteries, how many panels you need for sizing particular loads, either on-grid or off-grid. Okay. Somebody says, if I don't want to use smart load, can I or I need to use smart load compulsory? No, you don't need to use a smart load at all. It's just an added feature. It's like as utility companies become more and more difficult in terms of buying back your power, you want to shift your loads more towards the sun hours, and that's what it's about. And it's free. It's built into the system. Okay, so here's some of the new features that we've just introduced. We introduced AC coupling back in December, both on and off grid. We introduced small generator input support. That wasn't easy because those little small generators have up to about 15% THD, and they're incredibly noisy. They look nothing like a sine wave from the grid. That was a small mountain to climb. So anyway, we support small generators anywhere from 4 kW and on up. We also support big standby generators. And we actually sense the standby generator so that if we're doing full grid cell, we're not selling back into that standby generator. So that is now supported as well. All of these are just software updates which we can do remotely, and is shipping on all our current systems now. In addition, we've been doing some improved web monitoring. Here's a typical curve, you know, where this is just where you see, and here's how much power the whole house is using. Here's where I'm producing up to about 6 kW of power back to the grid, and here I'm consuming again. So this is a standard kind of curve. but some of the tools that we've added here are the ability to monitor, here's how much power I'm putting into the battery, or let's see, here's how much battery I'm putting into the power I'm putting into the batteries off the PV, and then here's how much power I'm pulling off of the batteries. So I can see where I'm using my batteries and how much, and then also we've got percent SOC and battery voltage meters, so we can see exactly what we're doing on the battery spectrum and where we're using those batteries for on-grid as well as off-grid purposes. And these are all available now. Somebody asked, where can we use the instant sizing tool? That's a good question. Please contact us about the sizing tool. There's the customized 8K system that's being improved vastly. That's about a week away. Is the panel level shut down through the use of an optimizer? No. We have found that optimizers are not needed at all. There's some studies from the InRail that show that optimizers do really nothing other than rapid level shutdown and monitoring. They help when you early in the morning and the late evening sun when they can get the voltage up higher, but they do nothing in terms of shading. And feel free to call us about that. We'll share the articles with you from NREL, National Renewable Energy Laboratories, but optimizers really don't do much. That's why utility grade solutions don't use them. Let's see. Okay. All right. Trying to answer the questions as I go along. Okay, so what are the upcoming features for the 8K? Let's see, this is Q1 and Q2. First of all, we want to do peak shaving for some of the residential and light commercial applications where they get hit really hard above, let's say, 8 kilowatts or something, and we want to utilize those batteries to limit our peak usage from the grid, because that's what they set our that little 15-minute peak usage is what they're going to set our whole or half of our bill on. So we're going to enable peak shaving, and also we're going to enable peak selling, so we can, any excess after we're using this time of use and using batteries during the night and zeroing our meter, if there happens to be any excess power that the batteries are already full, we'll go ahead and sell back to the grid. Even though we're going to get 5 cents per kilowatt, we'll go ahead and sell back to the grid and get that peak selling capability there. The next stage is 120/208, so that we can support 2 of the 3 phases of for light commercial power. So, we already designed for 50 and 60 hertz. We designed, and that's working. We're doing 220 and we're doing 120/240 split phase. But what we really want to be able to do is do the 2 of the 3 phases for 208 commercial power, and that's used in also used in some of the cities as well. They'll run 3-phase power to residential. So that's coming in March. And then this, we actually will be coming out in April with UL 1741 SA and California Rule 21 and HECO Rule 14H. That is a lot of work, but that's what we're focused on as well. And that will allow us to sell back power in Hawaii and California, even though they're not going to pay us, our customers, much for it. The customers still would like to have it. So anyway, and then also we're going to improve our web portal. We're going to support 4G. We'll support both Wi-Fi and 4G connection. The 4G just allows us to plug in the 4G dongle, and there's no Wi-Fi setup. I mean, the Wi-Fi setup has probably been the single biggest support issue for us, just because setting up Wi-Fi is not that fun. Okay, and another big announcement is in May, we will support IP55 outdoor case. This will allow us to go into a lot of outdoor applications because you can spray a water hose all over it and it doesn't care. So those are some of the things that we have planned in the next coming months. So with that, I don't think we'll have time to get into battery technologies. you're welcome to call us about that. But I wanted to see if there's any questions. Can the 8K power a 240-volt water pump without battery, solar only? No, it cannot. Well, I don't want to say that. Could it? No, it could not. The reason why is our system works. If it doesn't have batteries, it can't. It needs to be tied to the grid. So it couldn't. You know, it basically works like a grid tie inverter without batteries. So, and also you need that high peak power that a battery can provide to start up a 240-volt water pump. What other questions are there? Any questions? Any concerns about, does the 8K have internal data logging? Yes, it does. It has nice GUI graphical screens for the solar and the grid usage, so that you can see what it's doing on a per day, per hour. I mean, per few minutes. You don't have to do everything online, but the online tools can be very advantageous. So, we'll have some training webinars on the online tools in later sessions. What other questions can I answer for you? Is there anything that you have concerns about? Basically, we're trying to make solar plus storage affordable for your customers. That's the key thing. What is the no-load idle consumption? That is an excellent question, because that is important. Our no-load idle is 60 watts for an 8 kW inverter. There's a couple out there that aren't so good. Darfon, so 60 watts is equivalent to about one solar panel of energy a day over a 24-hour period. The Outback Skybox is actually somewhere, depending upon its mode. Right now, it's anywhere from 100 to 200. They're trying to get that down, but their idle is really high for a 5 kW inverter for Skybox. That may be why they're not releasing so many. And also, they don't publish their efficiency numbers because maybe they're somewhere around here. I don't know. And Darfon is also really high. They're about 100 watts per inverter to be, and these are two inverters to be fair in terms of peak power. Okay. Let's see. What happens if you slightly oversize the solar input, 36 panels at 330 watts each? Ooh, what is 330? I don't know. Let's see. 330 watts times 36 panels. That's 11. That's almost 12,000 kilowatts. I would suggest that you drop the number of panels to maybe 32 panels. If you're going to use 330 watt panels, you need to be somewhat, about 11 kW or below on sizing the array. Or that's where you can AC couple a little bit, AC couple with a few extra panels. Will there be a way for installers to monitor all of their installs? Oh yes, actually there is. There already is now. So we just have to set it up for you, and you can see your customers as well as they can see themselves. So we can make an installer login for you. Are you planning to add more MPPTs? No, we're not. It has 2 MPPTs that each handle up to 2 strings, so we find that that's more than adequate, in addition to AC coupling. Okay, when will the new firmware to allow grid tie cell mode and the whole house generator? We have systems in limited home mode waiting. That's available now. So we can update those systems any moment. Okay. Okay. Well, okay. And another question. How does your rapid shutdown work? Our rapid shutdown is a signal. So when you turn off the system or you hit an emergency button externally, then it shuts down the transmitter that goes to the SunSpec shutdown modules that are up by the panels, and so it we use either one per array or one per panel, and so as soon as they don't get that rapid shutdown signal, the PV panels they get cut off from the system. So the rapid shutdown, if you want some more diagrams from us, you can ask us and we're happy to send to you. But it's pretty simplistic. I'm not a big fan of rapid shutdown because of the cost. You know, I'm really leaning more towards ground mounts unless you have to mount it on the roof. Oh, I already answered that about MPPTs. No, we're sticking with two per string. Okay, so any other questions that I can? Let's see. Can you limit input amps so you don't overload small generators? Absolutely, you can limit. Oh, okay. So let me see if I have a diagram of that little. Yes. Oh, I don't have it. Under the charge tab. So we need to have a webinar where we cover all the different GUIs with the system for a more detailed overview, and you can see exactly the flexibility of the system. So we have a different charge rate for generators, for small generators, for this generator input port, as well as the grid port, or which you might have a big generator for. And that allows you to adjust the charge rates for either this charge rate is for the PV, and then there's a charge rate for the generator and a charge rate for the grid. So you have a lot of flexibility. And what we added just this year was the ability, so if your loads start going up, so a lot of times, let's say I've got a small generator, maybe a 7 kW, and I have loads increasing, and we used to just be able to, you know, so we want to decrease the charge rate of the system to the batteries if our loads in our homes go up, if we're off grid. So we basically can reduce the generator charge rates depending upon what our loads are. So this really helps take it easy on the generator and not overload it. So lots of things about generators that we kept coming into. How smooth is the RA process? Wow, we haven't had one, have we? I don't know. I haven't had one, I don't think, on AK. Pretty easy, I guess. Call us. Yeah. Okay. Okay. So I hope this has been beneficial and a learning experience. Let's see. Suggestions for bypass. Oh, okay. Basically, let me go to this. So typically, sometimes people want to bypass to go from grid to load in case there's some inverter failure or something like that. In fact, so what we did was we implemented several methodologies here that's called grid failsafe. And so what happens is if the computers inside here fail, for some reason, if there's some malfunction in the system, what it will do is it can smartly, if there's a grid present here, it can sense and connect the grid to the loads, in fact doing a bypass for you. It's rather smart. So there is a bypass built into the system. You don't necessarily have to do a manual bypass, although we haven't had to use that yet. Okay? Any questions else I can answer? I hope it's been beneficial, and I hope you see that we're working hard on this thing. We want this to be the best inverter out there if possible. If there is an RMA, we better have a bypass, right? Okay, all right. So somebody says, oh, if there's an RMA, we better have a bypass, right? Well, here, I suggest you get a couple wire nuts out and you wire the grid wires here to the load with the wire nuts, and then you can, if you have to have an RMA, you can That's a bypass with wire nuts right there. Grid to load. Use some wire nuts. There's your bypass. Okay. Anyway, I hope it's been beneficial. Feel free to call us, and we'll try and have some more technical details on the system. And I hope you appreciate it. Thank you very much.